As network admins, we spend a lot of time looking at routing tables. So let's take a few minutes and explore the routing table in a little more detail. So here's a basic IPv4 routing table pulled from a Cisco router. We display the routing table in a Cisco router by entering the show IP route command, or as you see here, shortened to ship route. So after we enter the IP route command, the first thing that shows up is going to be this list of codes. And we're going to use this list of codes to explain things farther on down in the routing table when we start looking at the route source. The first thing we want to look at in the routing table is the route source, and that's going to be this first column right here. And so you're going to see a bunch of codes, C, L, R, S. Each of these codes is explained in the code section that we just looked at. So if we look at the route source of C, we look up in the code section and we see that C means connected, L means local, R means RIP, S means static, so on and so forth. The next thing we want to look at is going to be the route destination, and we're going to see that right here. So this gives us our destination network ID and our subnet mask. So it's 192.168.1.0/24. Now the /24 is how many bits in the packet destination address have to match this pattern 192.168.1.0 in order for this route to be a viable destination for that particular packet. When a router chooses its the route that it's going to use to forward traffic, it will find and use the route with the best match to the destination address specified in the packet, and the best match is identified as the one with the most matching bits, or the /24, or however many bits are in that particular routing table entry. For a directly connected route, the next thing the routing table entry is going to say is directly connected, which you can see right here. That is directly connected normally means that this is a directly connected route, which means we actually have an interface on that network. That's not always the case. To confirm that, you want to go back over and look at the route source column that should say C or L, and that means you actually do have something on this. You can also have routes that have a exit interface rather than a next hop, like this static route right here, which also says is directly connected, even though that whole network isn't 0.0.0.0/0, it's a default gateway. Even though that whole world is not directly connected, because we have an exit interface rather than a next hop address, it's still going to say is directly connected. So back to our directly connected route, the last thing on our directly connected routing entry is the exit interface, which you see right here. That is the interface that is directly connected to this network and that we will use to forward packets out to this network. So that's a directly connected route. What about this L here? So an L stands for a local, or what that means is that is the local interface, our interface, the router's interface on that directly connected network. So what about remote routes? A remote route is a route that the router cannot learn about automatically. The only thing it can learn automatically is directly connected routes. Remote routes, it has to learn from a routing protocol or from a static route that the administrator manually puts in. Now this right here is an example of a remote route. So let's start by looking at the route source, and you're going to see that right here. And this R indicates that this is an RIP route, or we learned it from the RIP routing protocol. The next thing we want to look at is this 120 right here. This is the administrative distance of the route source, and RIP has an administrative distance of 120. The next issue is the second number in the square brackets right here. It's the number that comes after the slash. This is the route's metric. So that is the metric, or the distance, to actually get to the route. Remember, administrative distance doesn't measure actual distance. It measures the trustworthiness of the route source. The metric is what measures the actual distance. And remember, metrics cannot be compared across routing protocols. Since they use completely different metrics, there's no comparison whatsoever. So this is the RIP metric, which is hop count, of 1, or the distance to this particular destination network. For a remote route that uses a next hop address, we are going to see this right here, which is via and then an IP address. Now, via means that this is going to another device, another next hop, and we're identifying the IP address of that next hop. And that's what this IP address is. So if something comes in for this destination network, we will forward it to this particular IP address to get it one step closer to its destination. The next thing we want to see is the exit interface, or how do we get to our next hop address? And we're going to see that right here. This identifies the exit interface for this particular route. And the last thing we want to look at for a remote route learned via routing protocol is this column right here. And this is our timestamp. So this is how long ago we got an update about this particular route. The next thing we want to look at in our routing table is the default gateway, and we're going to see that in two places. So the first one is right here, and that identifies our gateway of last resort. Now we're also going to see that replicated down here with this line. So the top line, gateway of last resort, is, and then 0.0.0.0 means we don't have a next hop. That is a directly connected route, and we'll see that down here in the second line that we highlighted. The static route is directly connected. So back to the top line, it says the gateway of last resort is 0.0.0.0, or directly connected. We don't have a specific IP address, to network 0.0.0.0. And that means any network in the world. If you look back down to the static line, you're going to see that when this one down here at the bottom, you're going to see it's a static route, 0.0.0/0, which means anything matches, is directly connected through serial 001. Now the other thing I want you to see is this little asterisk right here. If we look back up in the codes, we're going to see that that indicates that this is a candidate default route, or our default gateway, or our gateway of last resort. So let's talk about level 1 and level 2 routes. Now a level 1 route is going to be a route like this one right here. And we're going to identify it by the fact that it is aligned farther over to the left than a level 2 route. A level 2 route is going to be something that looks like this one right here. You're going to see it indented underneath a level 1 route. We recognize a level 1 or level 2 route by the way it's indented in the routing table. But what makes it a level 1 or level 2 route is this right here. This is the number of bits that are involved in the route. If the number of bits is equal to or less than the number of bits in the default classful subnet mask, then it's going to be a level 1 route. Now in this case, the /24 is 24 bits, which is the same as a Class C default subnet mask, and 192.168 is a Class C address. So since the /24 is the same or less than the number of bits in the classful subnet mask, that makes this a level 1 route. Level 1 routes can be either parent routes or ultimate routes. So let's look at this first example right here. This is a level 1 parent route. What makes it a parent route is the fact that it does not have an exit interface or a next hop address. If you look at this route right here, this is a level 1 route. Notice how it's aligned all the way over to the left. It is an ultimate route because it has a next hop address via 192.168.2.2, and in this case a serial interface as well, or an exit interface, serial 000. So this is a level 1 ultimate route. Let's go back up to this level 2 parent route, or level 1 parent route, which is the one up here at the top. We look at that line, 192.168.1.0/24 is variably subnetted. It includes 2 subnets and 2 different lengths of masks. This parent route is a header route that simplifies searching the address table. We can't forward data out this route, but we have 2 child routes, and we're going to see those right here. And these child routes align underneath the header for the parent route. They are level 2 routes. All level 2 routes are child routes. And they are ultimate routes because they have a next hop interface, or in this case, a exit interface. All child routes are always level 2 routes, and they're always ultimate routes. So like we said at the beginning, as a network administrator, we're going to spend a lot of time looking at routing tables. Hopefully now you have enough information to help those routing tables make sense.